Hello friends, सबको नमस्ते. So today in this video we will create a image classification web app and we use multiple models. You can see that we have a models of brain tumor and chest X-ray. Before explanation, let me first show you how our web app look like. Okay, so open the terminal and just type. You have to type Streamlit run app.py. Just enter it. It will automatically open a browser. So this is the interface. This is the interface of the web app. Okay, the you can say the default model selection is a brain tumor. Let me first choose one image for that. So where is brain tumor? This is. Let me first select this image for no brain tumor. Then run classification. The spinner will come. See, it displaying the message like this: prediction, confidence, and model use. Now let me select one different image, chest X-ray. Then again, let me select pneumonia chest X-rays. Run classification. Again, spinner, and see prediction, pneumonia, confidence, model used. Okay, so this is a web app which we create, and then I will explain you whole code. Okay, okay. So let me explain you each and everything. So this is a data dictionary which contains as a key brain tumor, chest X-ray, and these are the class names and the weight name. Okay, same way, class name and weight name. Weight name, you can see that weights are stored here. Brain tumor, and the model and the framework for the model which we are using is TensorFlow. Okay, so these are the weights name which is stored here. See, this st dot set page config page title and layout will be white. What this line show? So go to the browser. It's showing this thing, medical image classifier. Okay, so this line display this medical image classifier and the layout will be white. Now to display this to display this image, this image as a background, we will use you can see this is an image for the background. Okay, so for that this is a image path. Then we will use when we have to encode this image to display that particular image as a background, we have to encode it. For that we use get base image function in which we pass the image pass the parameter as an image path, and we will come to this function in which we open this image path, means image file in the reading board in a binary format. And after that we will use this base 64 as a package to encode it in the base 64. And when the image is encoded, you can see that image file, this image file dot read, then decoded. Okay, then the encoded image we can get it. And when we got the encoded image, this variable basically store in this. Then using this css, means st.markdown, and this is a css, you can see that style st.app background image will be url. This is a this way you have to uh, give the bg image encoded. Okay, then the size, then the position, then the repeat, no repeat will be there. Okay, dot st dot app basically this describe the entire app, web app. And unsafe dot allow html. So whenever this whole thing run, it set the background of the web app. Now see, now we have to display this medical image classification. For that first, this is for display it we use st.markdown division means HTML, then a class will be title, semantical is a text, and unsafe allow HTML true. And the CSS for this, you can see this class is title, you can use this st.markdown, and this is the CSS for that. You can see that style dot title, text align, font size, color, font width, margin to top. Okay, minus 60 pixel because you can see that by default, if I will not use it, by default it's come to down here. To move up, uh, for better explanation, let me show you the result of it. Let me erase it, then save it, then again run this. You can see that it will come down. Margin from the top will be margin from the top will increase. See, margin from top is very high. Okay, so to decrease this margin from the top, I have to use this. I have to use this margin top minus 60 pixel. Okay. After this, when we set the title, then this is an important thing that we have to use the drop down button. You can see that uh, to display this drop down. Okay, this choose a classifier model, this drop down box. We will use this st.selection, and this is a text which we want to display, and what we want to display inside the drop down, we will use for that we use data.keys, and when we get the keys, it is convert them into the list format. So after that, then the model data will be, see, these are the keys: brain tumor, chest x-ray. And by default the initial model which is selected by default is the first one, and the first one will be brain tumor. And this, when we pass this model name, that model name as in a data dictionary, you can see that data dictionary, and by default brain tumor. So this whole information related to the brain tumor key is stored in this model data variable. Okay, after that we want to display the drop down box, or the box on which we can easily fetch the image from the from our personal PC. For that we will use st.fileuploader, and this is a text which we want to display, and this is the image which we allowed. Okay, jpg, jpeg, and png. Uploader file means whenever we upload the file, this file is saved in this variable. If suppose whenever the user upload the file, this whole code will get activated. If upload file, first we open that image and convert that image into RGB, because it might be possible that image which is sent by the user or upload by the user, it might be grayscale, uh, but our model required image should be in RGBs. For that we require it. Now here initially first for the prediction will be none. Let me when I will explain you below code, then I will explain the reason that why I have initialized it prediction is equal to none. Okay, now you can see that this is the image, this is a button, and this is a prediction. Means this is a whole this whole is a 3 column. Okay, so same way I have created a 3 column: column 1, column 2, and column 3, and st dot column by using st dot column. And this 1.21 and 1.2 here, this is a width of each column, and the gap between these column will be I am using large. Now in column 1 you can see that in column 1 I am just displaying the uploaded image. So just st.image, then pass the image which we want to display, this image. Then user container width will be true. Caption which we want to display below the image will be uploaded image. Now second thing, in second column I am to display this button, and you can see this button is margin from the top is about to 2 br. In HTML, 2 br has a br is basically the keyword which is or not keyword, is a tag which provide a blank space from the top. So st.markdown, this is a column 2 which we want to display. In column 2 we want to display, first we have to display the blank space from the top. For that we use br, then unsafe html.true. Then after that we have to display this run classification button. So for that, this is a style, this is a css for that. For that you can see that style.div.st.button margin from left will be 30%, and this button will display if st.button means whenever, if st.button means whenever a user click on this activated and the spinner get activated. And when the spinner get activated, this ultimately compiler will come to classifier function, in which we are passing image model data, mean weights name and a class name. Okay, so compiler classifier, the classifier function, you can see that classifier function come from the model folder. And in model folder I already created this init file, so you can see that from where it's coming from the classifier classification folder. Inside the classification folder it have a classify python file, and inside the classify python file it have a classifier function. So classification classify has a python file, and inside it has a classifier function. You can easily see that we are passing weight name and a class name. Okay, weight name, class name, and an image. Then we have to pre-process the image, because during training time we process the image for training. So first thing is that the model require image should be in grayscale. Then we want the size of the image should be 224. Then we have to convert that image into array to add to expand the dimension of that. For that we use np.expand dimension. Access will be 0 and image predict. So what is use of this? First thing is that during training we pass the images in a batches format. So during testing time it is necessary that you have to pass the image in a batch format only, but during testing time we pass only one image. So to add this batch dimension in it, we use this np.expand dimension image predict, and access will be 0. It add one dimension to the image. After adding the one dimension, I just to normalize the each pixel and and then pass the image. After getting the image, first we have to create the model. So for that, first we have to get the weight path. For that, this is the way which we can create a weight path. Means where the path or join OS path directory, then two dot, then weights folder, go to the weights folder, and weights means the parameter which we getting. Then for loading the weights, we have to use tf.keras.model.load model weight path. Okay, this way we load the model and the model are ready for the prediction. Then just use model.predict, then pass the image, preprocess image, and this 0. After getting this output, we want a prediction. So we are just passing one image, so index 0 will give me the prediction of image which we have passed. Now we have to get the index value on which the highest probability or score is present. Okay, for that we use np.argument_max, then prediction, then access value -1. We get the index value on the highest probability where value is present, and this highest probability value is actually the score. So how we can get it? Just see, in prediction means in this, give the prediction index, we will get the score. Then after getting the score, we have to round it to 4 value. After rounding it 4 value, we have to multiply it with 100, and after multiplying with 100 we have to convert that whole thing into the int. This way we get the score. Now for getting the label, we have to use just label class names. This is the class name, just pass the predict index, we get the label. Then we, after getting the score and label, just pass this label and score, and ultimately the compiler will come to here. And after getting this label and score, we will use prediction will is equal to prediction have some values in a tuple format, label and score. That's why, because here prediction is act as an indicator. So initially its value will be none. When there's get some value, you can see this in column 3 if prediction. Okay, and then easily we can fetch this label and scroll and just display the masses. You can see for displaying the masses we are using 2br, means blank space from the above. So this way we created the Streamlit code as a web app. So let me now run it. Okay, it's not open my browser because I have directly run this file, but this is not a way to run the Streamlit code. For running the Streamlit code we have to use streamlit run.app.py file. Now it will open my browser. You can see that. Wait a second, I want to explain one thing also. You can see that by default the model which is used by the Streamlit is brain tumor, because brain tumor is as a first key in a data dictionary. Okay, that's why. See, that's why the data which we are using is storage of the brain tumor at first. So let me first choose brain tumor chest x-ray. Let me select one image for normal brain tumor. Then we have to click on run classification. Then the spinner will come. You can see that. Then when we get label and score, it will hide. See, this way we get the prediction, no brain tumor. Now let me select one image where there is a brain tumor. Then again run classification. See, brain tumor. Okay, so display the predictions is display. Now let me select different chest x-ray. Now again browse the image. Run classification. See, normal. Okay, now let me select one image where there is a pneumonia. Open it. Then again run classification. See, pneumonia, confidence, model use. So this is a web app with multiple image classification model we are using. Okay, so I have already explained you each and everything here, how it's working, every line. So please like, share and subscribe. Thanks to all.